Hello and welcome to this video. In this video we're going to be looking at how to calculate the surface area of any 3D shape. Okay, so in general what we mean by surface area is we could work out the area of a two-dimensional shape. So let's say for example assume this was a perfect square where this was 2 centimeters by 2 centimeters, and we know that the area of a square is just base times height, so this was just going to be 4 centimeters squared in the middle here. So this would be the area of a 2D shape. When we have surface area, we have to make these things three-dimensional. So what we're going to look at is, let's take an example of a cube here. So I'm going to take this same thing here, but I'm just going to make it three-dimensional. So I have 2 centimeters by 2 centimeters of a square, assuming it was perfect, and then to make this a cube, we just have to go 2 centimeters back. So this is 2 centimeters going back into the page, 2 centimeters going across the page, and 2 centimeters going up the page. Now we want to work out the surface area. So the surface area, we already know what one of the areas is, because this front face here is a 2 by 2 square. So this front face has an area of 4 centimeters squared. However, in total, if we were to make this more obvious, we actually have 6 faces on a cube, meaning that we have 6 times the surface area. So the surface area is we just have to find the area on each surface and add them all up. A cube is quite a nice example because we know the area of each surface is exactly the same. So we're just going to have the 6 sides multiplied by the area of one face, and so the total surface area of this cube is going to be 24 centimeters squared. Let's try looking at it now in terms of a cuboid. Okay, so very similar to a cube, we've basically just stretched out one or two of the sides. Let's say that our cuboid looks like this and then goes back like this. Okay, so let's say this has a side of 8 centimeters, this is I don't know, 3 centimeters, and this going up here is 2 centimeters. Okay, and they might want us to work out the surface area of this cuboid. Now it's still a cuboid, so it still has 6 faces, but not all 6 of them now are the same. So I would split this into pairs. So we could say that the front face, this one here, is going to have the same area as the back face. Okay, so we can work out the area of the front face first, and then we could have that's going to be 8 centimeters across by 2 centimeters up, so that's going to be 16 centimeters squared. Then we can work out the area of the side face. So this side here is the same area as that side over there. So that's then going to be the area of the side. Notice I'm only doing one face for each, and I'm going to double them at the end. Is a 2 by 3 centimeter side. So that's going to be 6 centimeters squared. And then lastly, I have to do the top and the bottom. Okay, because those are going to have the same area as well. And the top is going to be 8 centimeters across by 3 centimeters going into the page. So the area of the top face is 8 by 3, so that's going to give me 24 centimeters squared. Now this is just 3 faces. I know there's, like I've said, the front face is the same as the back face, the side faces is the same as the other side face, and the top is the same as the bottom. So I can double all of these things since there's 2 of each area face. 16 times 2 gives me 32 centimeters squared, 6 times 2 gives me 12 centimeters squared, and 24 times 2 gives me 48 centimeters squared. And then I'm just going to add all of these up, and that should give me 92 centimeters squared in total. So now we know how to work out the surface area of a cuboid. Now let's have a go at going for a more cylindrical shape. Let's work out how to work out the surface area of a cylinder. So a cylinder is now going to be quite a weird one, since we have a curved surface. Okay, so this cylinder has a curved surface going around the edge of it, and working out the area of a curved surface can be quite difficult. So what we're going to say is, what we can tell is we can know, they'll tell you the radius of this circle, and they will tell you the height of this cylinder, and that's all you need to know to be able to work out both the surface area and the volume of a cylinder here. But the cylinder has a circle on the top that's the same as the circle on the bottom. So we can first work out the area of the circles. And I'm going to do this all algebraically first, so I can get some kind of formula that you could memorize, just to show that it can be done like this. But also I'll have a go at an example using some numbers. So the area of the circles, we know the area of this circle is pi times the radius squared. Since we've got a plural here, it's both of the circles, we have two of them, so the area of the circles is 2 times pi r squared. Okay, now the curved surface is quite interesting. So the way I always imagine this is, imagine it like a toilet roll holder. Okay, that's got a curved edge to it, but imagine you cut a line down one edge of the toilet roll holder and then you roll it out. When you roll it out, you're going to end up with a rectangle, because you're basically saying this is the cut that you've made, you roll it out and you get a rectangle. Now this height here is the height h. Okay, so we already know that, but this here is the length around the edge of this circle, which is the circumference. And to work out circumference, just to make a side note, the circumference of a circle is pi times its diameter, or we're going to write it in this case as 2 pi times r. So the 2r gives you the diameter, and we've just written it like this to try and make it look something like this. Okay, so this is 2 pi r. And now we can work out the area of this, because it's just a rectangle. So the area of the curved edge is just 2 pi r times h. Okay, so now we can work out the total surface area is just going to be the sum of these things. So it's going to be 2 pi r squared plus 2 pi r h, and we could actually factorize this so that we could get a conclusive surface area of a cylinder. We could always work out by 2 pi r, since we've got 2 pi r in both of these, and then we're left with just r plus h. So this would be your formula for the surface area of a cylinder, just 2 pi r times r plus h. So let's have a go at a question now where I'm going to put some numbers in. So let's say we had a cylinder that was had a radius of let's go 3 centimeters, and we had a height here on this cylinder of 5 centimeters. So it's a relatively small cylinder. We can, now that we know this, now that we have this idea of how we're getting to this formula, we could just put it in and say that the surface area, which I'm just going to call SA, is 2 times pi times 3 times 8. So 8 coming from the radius plus the height. And this is going to give you 6 times 8, which is 48 times pi centimeters squared in total. Now this would be leaving your answer in pi. If you wanted to put it into decimal form, you can just put this into a calculator, and this will give you a surface area of 150.8 centimeters squared to 1 decimal place. Okay, so these are cylinders. Let's now go even further and let's have a look at a sphere. How would we work out the surface area of a sphere? So deriving this formula is going to take a lot more maths knowledge than what we've had before, so I'm just going to quote the answer to you. So let's say I have a sphere like this, assume it's 3-dimensional, and it has a radius of a sphere r. Now the surface area of a sphere is given by 4 pi times r squared. Okay, this is the formula for your surface area of a sphere. So let's say I change this r and I make the surface area out of 5 centimeters. I would then just put that into here. It would be 4 pi times 5 squared, which would give me 25, and this would give me 100 pi, which would give me 100 times pi gives me 314.2 to the nearest centimeter squared to the nearest 1 decimal place. Okay, so that's how we work out a sphere. Now we can also be asked finally to work out the surface area of a cone. So a cone looking like this, we're going to note the height here in the middle as h, but this slanted edge is going to have a different formula, which we're going to note as s, and the base of this is simply just a circle, which is going to have some radius r. Now we know what the area of the circle at the bottom is, so the area of the circle is pi times r squared, but again we have a curved edge. Now this curved edge, when we roll it out, isn't going to be a nice rectangle as it was in the cylinder case, but there is still a formula that we can use to be able to find out what it is, and the area of the curved edge in the case of a cone is going to be pi times r, so the radius across the bottom, times s, the slanted length. Okay, so it's important that this is the slanted length and not the height h. Okay, and then therefore to get the total surface area, so the surface area of a cone is just pi r at r plus s. Okay, so that's from, if I write that out more explicitly, it would be pi r squared plus pi r s. I can pull out a pi r in both of these, and I'm left with just one r and an s. So this is almost very similar to the cylinder case. We've just changed a few of the variables. So this is how we're going to work out the surface area of these 3D shapes. They can sometimes give you more complicated shapes. So they might give you, for example, a compound 3D shape, meaning that it might be, for example, so compound 3D shapes. We're going to take all of the shapes that we've just looked at, and we're basically going to put them all together. So we might have a cuboid with a let's say with the triangular prism on top. So a triangular prism is not one that we've looked at, but it follows the same rules. And let's say that this just does this kind of thing, and this is your compound 3D shape. And they might ask you to work out the surface area, given that this has some length, maybe 8 centimeters. This goes back by 2 centimeters, and this has a height of this line, the cuboid, has a height of let's go with 5 centimeters, and this triangle has a height of 6 centimeters, for example. And they might ask you to work out the surface area. Now all we do is just separate this the same way we did when we looked at the area of compound shapes. We're going to separate this into the compound 3D shapes, or the simple 3D shapes. So this is going to become a triangular prism like this. So this is a triangular prism with the lengths. This bottom is 8 centimeters, this up here is 6 centimeters, and going backwards was 2 centimeters. So we can work out all the surface area of this. If I just make it a little bit more obvious by putting this 3-dimensional stuff in there. And then we also have to work out the surface area of this cuboid that they've given at the bottom, that has 8 centimeters by 5 centimeters by 2 centimeters. And all we do, if I again make this a little bit more 3-dimensional, all we do is find the area of each face and add them all together, really. So this triangular prism, for example, the area of the front triangle and the area of this back triangle are going to be the same. And we know the area of a triangle is a half times base times height. So the area of the triangles is going to be 6 times 8 divided by 2. Now 6 times 8 gives you 48, and 48 divided by 2 gives you 24 centimeters squared. So that's both of these, that's just one of these triangles. In order to get both of the triangles, we have to double this, but we're going to do that later. Now this triangular prism gets a little bit weird because we have a bottom face, a back face, and this slanted face that are all going to have different. So we'll say AB for the one across the bottom is 8 by 2. That's going to be 16 centimeters squared. Actually, we wouldn't have to do that in this case because the 16 centimeters squared is going to be enclosed on the top of this face. So this bottom face doesn't actually count for anything, but we do have to do the back face and the forward slanted face. So the back face is going to be 6 by 2. So let's call it back so we don't get confused with the bottom face. A back face is going to be 12 centimeters squared, and the slanted face, well, this slanted side is going to get a bit more complicated because we're going to have to use Pythagoras. But I can just tell you that if we did Pythagoras and we had 6 squared plus 8 squared all square rooted, this is a Pythagorean triple, so this slanted length is 10 centimeters. Now, whether they make you work out this slanted length or they give it to you is really dependent on where you're going to find this question in the paper. If it's quite a paper near the middle of a section, they'll probably just tell you. If it's a question near the end of the paper, they're probably going to make you work this out for yourself. But this slanted area is going to be 20 centimeters squared. And don't forget to come back here, and we're just going to double this number because we have 2 triangles. So let's make that 48. And now remember, we don't have to work out the top face because that's the same as this bottom face and it's closed off in this shape. But we do have to work out the other 5 faces. So let's say the area of the sides, so this side and this side, is going to be 2 by 5, so that's 10, but we've got 2 of them, so that becomes 20 centimeters squared. And the area of the front and the back, so area of front plus the back is 8 by 5, so that's 40, but times by 2 gives you 80 centimeters squared. And the area of the base, so the area of the base, the bottom of this is 8 by 2, which is just 16 centimeters squared. And then to get the total surface area is going to be the sum of all of these areas, so it's 48 plus 12 plus 20 plus 20 plus 80 plus 16. And when we work out what that is, 48 plus 12 plus 20 plus 20 plus 80 plus 16, it gives you 196 centimeters squared. So this is maybe the most difficult question that they can give you, is where they give you compound shapes and you have to work out quite a lot of sides and add them all together at the end. But hopefully this isn't too complicated. So what we said before is that in order to calculate the surface area, we just have to basically find the surface, the area of each surface, and then sum up all the surfaces. So we've been given a cuboid in this first question. They've given us the dimensions of this cuboid, but I'm just going to draw in the back here kind of a crystal viewing. Let me do that a bit more accurately. So this is the view if this was, say, a glass cuboid, just so that we can see the different faces, so we make sure that we're accounting for all of them. So we said for cuboids, the area of the front face is the same as the area of the back face. So let's actually just call this the area of the front plus the area of the back. Well, this is a 6 by 1.5 centimeter face here. So it's going to be 6 times 1.5, which is going to be 9, but 9 centimeters squared for one face, so 18 centimeters squared for both faces, front and back, just by multiplying it by 2. Then we get the area of the sides, This side over here is a 1.5 by 1.5 area, and 1.5 by 1.5 is going to give 2.25 centimeters squared. But remember, we have two sides, so this shape, this area over here has to be the same as this for it to be a cuboid. And so when we take the 1.5 times 1.5 is 2.25, and then we times that by 2 to get both areas, we get 4.5 centimeters squared. And so we've got front and back, side, side. Now we just need to look at top and bottom. So the area of top plus the bottom is, at the top we have a 6 centimeters by 1.5 centimeters, and 6 times 1.5 is going to give us 9 again. And that 9 we're going to times by 2 to get from the top to the bottom, so we times by 2 to get both of them, and it gives us another 18 centimeters squared. Now that we have that, we can get the total surface area is just going to be 18 plus 18 plus 4.5, which 18 plus 18 gives us 36, and then plus the 4.5 is going to get us up to 40.5 centimeters squared. And this here is our total surface area of this cuboid. So now let's go a little bit more difficult. We've now been given a pyramid where they've told us that the height of the pyramid from the very center is 4 centimeters, and they've told us that this slanted length here is 5 centimeters, and they want us to, the base is a 6 by 6 square, and they've said M is the midpoint, and VM, so V to M, the slanted length is 5 centimeters. They want us to work out the total surface area of this pyramid. So we need to look at the area of the base. It's probably the easiest because it's 6 by 6. So 6 times 6 is going to give us 36 centimeters squared for the base. Now each of these triangles, these slanted lengths are going to be the same. And so if we were to take just one of them, it would look like this, where the base of it is still the 6 centimeters that we have in the question, and the height of all of them are all 5 centimeters. And so the area of one triangle is 6 times 5 divided by 2, since it's base times height and then halved. So this is going to give us 15 centimeters squared, but we have 1, 2, 3, 4 sides that are this length. So the area of all the triangles, we're going to have to times this by 4, and 15 times by 4 is going to give us 60 centimeters squared. And then we just have to add the base to all the triangles. So the total surface area is 36 plus 60, which is 96 centimeters squared. And this gives us the surface area of this pyramid. Finally, or not finally, but next along is we have shape S is 1/4 of a solid sphere about the center O. So the volume of S is 576 pi centimeters cubed. So we're going to have to employ the knowledge we have about volumes here as well. And they want us to find the surface area of S. So the reason they've given the volume is because they want us to first find the radius of this sphere. So if we know that the volume of a sphere is 4/3 pi r cubed, but S is 1/4 of a solid sphere, then we have to divide this by 4. These 4s are going to cancel, and so actually what we'll be left with is the volume of this shape S is just 1/3 pi r cubed, and that's equal to 576 pi. Now we have a pi on both sides here, so we can cancel pi, and then r cubed is going to be 3 times 576, multiplying this 3 up here. So r is going to be the cube root of 3 times 576, and 3 times 576 gives you 1728. So if I take the cube root of that number is just 12. So r is equal to 12 centimeters. Now I know it's centimeters because this volume up here is in centimeters cubed. But this isn't the answer to our question. What we want is we want to work out what is the surface area of this. So our surface area, like we've always said, is just the sum of all the areas. So we have this semicircle here, and this semicircle here are going to have the same area. And so we can find the area of just one semicircle. So if we think about having a two-dimensional semicircle like this with a radius of 12 centimeters that we've just found, the area of a semicircle is going to be the area of a full circle divided by 2. So it's pi r squared over 2, but we actually have 2 of these faces, so the total area of that is just going to be pi r squared, because when we multiply it by 2, the 2's will cancel. And so the area of both of these faces, both of these semicircle faces, is going to be 12 squared, which is 144 times pi. So we have our first area. The second area we have to work out is this curved edge that's going to come around the back. Now we know from up here the surface area of a sphere is 4 pi r squared. So if we wanted the surface area of a sphere, it would be 4 pi r squared. But now we have to remember this is 1/4, so we'd have to divide this by 4, and those 4's are going to cancel. So once again, this is just going to be pi r squared is the curved surface area at the back, which is exactly what we had before. The radius is the same, so it's going to be another 144 pi. And then we just sum those together, so we have 144 pi plus 144 pi gives us a total surface area of 288 pi, and they're asking for our answer to 3 significant figures, so we just have to times that, put that into a calculator. So 288 times pi in a calculator gives you 905 to 3 significant figures. Just remembering the units, it's going to be 905 centimeters squared, because it's a surface area, to 3 significant figures. There we go. Okay, now finally we have another pyramid, but in this case we've been given a lot less information than what we were given in the first pyramid question. So what we've been told is that the base is a square of sides 20 centimeters each, but the angle between any sloping edge, so maybe VB or VC or VD or VA, and the plane ABCD is 55 degrees. And they want us to calculate the surface area of the pyramid correct to 2 significant figures. So once again, first thing we can do, work out the area of the base. That's going to be fairly straightforward, because it's just going to be 20 times 20, and 20 times 20 is going to give us 400 centimeters squared, and we can set that aside. We now need to work out what is this distance here. Okay, and what we've just been told from this line is that if we were to just look at that one triangle, this angle here is 55 degrees. Since what we're saying is that if we rotate around this at any point, this angle here is 55 degrees, this angle here would be 55 degrees, so would this one, so would that one and that one, and basically any of these things are always going to be 55 degrees. So what we can say now is, if I can put a half down here, I know the full length from here to here is 20 centimeters, because that's just the length of this base. So if I'm just going halfway across to try and get to the highest point, this is now a 10 centimeter line. And I can use a little bit of trigonometry here to be able to work out this length here. And so I have my hypotenuse over here, this is my opposite, and this 10 centimeters is the adjacent. So if I'm working with an opposite and an adjacent, remembering SOHCAHTOA, opposite and adjacent is going to give me a tan. So tan of 55 is going to give me my opposite, which I'm going to call x, over my adjacent, which is 10. Therefore x is going to be equal to 10 multiplied by tan of 55, and that we can put into a calculator, and 10 times tan of 55 is equal to 14.28 centimeters. Now I'm keeping these to more than two significant figures here, just so I'm ensured that I'm going to get the right answer, because if I times this by 4 now, it's going to be slightly different than if I just times 14 by 4. So this is the height of this triangle. If we want to work out the area of the triangle, so the area of the triangle, just one of these is always going to be base times the height divided by 2. In this case, the base is 20 centimeters multiplied by the height, which is 14.28 centimeters, and divided by 2. But we've got 4 triangles, so we're going to times that by 4, and that means that this 4 and this 2 can cancel, and that's just going to end up being a times by 2, because 4 divided by 2 is going to be 2, and so this is actually going to give us a total of 571.26 centimeters squared. And then I'm going to add in my two areas. So my total surface area is 400 plus 571.26 is equal to 971.26 centimeters squared. But I only want it to two significant figures, so I can get rid of this and just call it that my surface area is 970 centimeters squared. And there we go. That is probably one of the hardest surface area questions that you'll be asked to do, mostly just because it involves this trigonometry down here, but hopefully it all makes sense, and we'll see you next time.